There's a planet in our solar system where a single day is longer than an entire year. Daytime temperatures can soar to 800 degrees Fahrenheit, hot enough to melt lead, while nighttime chills plunge to minus 280 degrees Fahrenheit. This is Mercury, the closest planet to the Sun, holding shocking secrets about the origin of our solar system, and most terrifying of all, scientists have just realized that Mercury is shrinking, and this process could change the entire fate of our solar system. Mercury is a cosmic paradox. The smallest planet in our solar system is only slightly larger than the Moon. Yet it's nearly 4 times as massive. Why? Because hidden within its tiny frame lies a massive iron core that makes up 75% of the planet's entire radius. A proportion unmatched anywhere else in the solar system. But Mercury's weirdness is just getting started. It's locked in a unique orbital resonance, spinning on its axis exactly 3 times for every 2 orbits around the Sun. This means a single day on Mercury lasts 59 Earth days, while a year is only 88 Earth days. In other words, if you had 2 birthdays on Mercury, you'd have only seen the Sun rise once. Conditions on Mercury's surface are so extreme, they almost defy logic. During the day, temperatures soar to 800 degrees Fahrenheit, hotter than some household ovens. Metals like lead, zinc, and tin would melt into shimmering pools of liquid. But just a few hours later, as that part of the planet rotates away from the Sun, the temperature plummets to minus 280 degrees Fahrenheit, colder than liquid nitrogen. And here's the real shocker. Despite being the closest planet to the Sun, scientists have discovered water ice inside craters at Mercury's poles. These icy patches survive because the craters never receive direct sunlight, creating permanent cold traps on the planet's surface. To generate a strong magnetic field, a planet typically needs 3 things: a liquid metal core, fast rotation, and a large size. Mercury only checks one of those boxes. It has a liquid metal core. It rotates very slowly and is incredibly small. According to existing theories, Mercury shouldn't have a magnetic field at all. But when NASA's Messenger probe arrived at Mercury in 2011, it discovered something unexpected. Mercury does have a global magnetic field. Although it's just 1% as strong as Earth's, its existence makes no sense according to the planetary physics we currently understand. What's even stranger is how Mercury's magnetic field interacts with the solar wind in a truly unique way. Because the planet is so close to the Sun, the solar wind that strikes it is 10 times stronger than what we experience on Earth. This intense bombardment creates a constantly fluctuating mini-magnetosphere around Mercury. Most astonishing of all is the discovery of magnetic tornadoes near Mercury's poles, twisting magnetic field structures that channel scorching plasma from the magnetosphere directly to the planet's surface. This phenomenon has never been seen on any other planet. Scientists now believe that Mercury's magnetic field may be generated by a thin layer of molten outer core, while most of its inner core remains solid under extreme pressure. But the exact mechanism remains one of planetary science's biggest mysteries. But that strange magnetic field isn't the only bizarre thing about Mercury. Scientists recently discovered that the entire planet is shrinking, like a raisin drying out, and this process may have been going on for billions of years. The terrifying part? It hasn't stopped. Mercury's surface is covered in geological structures called lobate scarps, towering cliffs formed when the planet's crust was pushed and folded. These massive ridges stretch for hundreds of kilometers and can rise up to 3 kilometers high. They're living proof that Mercury is literally shrinking. As Mercury's massive iron core cools down, it contracts. But since the planet's crust has already solidified, this shrinking causes the surface to buckle and crack, like the wrinkling skin of a drying apple. Scientists estimate that Mercury has shrunk by about 7 kilometers in radius. That's like the entire planet losing weight in the form of tens of thousands of cubic kilometers of volume. But why does Mercury have such an unusually large iron core compared to the other planets? This is one of the biggest mysteries about how our solar system formed. Proportionally, Mercury has the largest core of any planet, even larger than Earth's, despite Earth being far bigger overall. Scientists have proposed 3 main theories. Condensation theory. Mercury formed very close to the hot, young sun, so only high melting point materials like iron could condense there. Evaporation theory. The early sun emitted intense energy that vaporized much of Mercury's silicate mantle, leaving behind mostly its iron core. Giant impact theory. Mercury was once much larger, but was struck by a massive asteroid that stripped away most of its outer layers. Each theory offers a different view of how planets might form in the inner solar system. And if the impact theory is true, it means planet formation may have been far more violent and unpredictable than we once believed. This one fact about Mercury is changing how we understand the formation of our solar system. If you're curious about more cosmic mysteries, don't forget to like this video and comment which planet you want us to explore next. But the most terrifying thing about Mercury hasn't been revealed yet. This planet might directly impact the orbital stability of other worlds, including Earth. And scientists have just realized something deeply unsettling about Mercury's future. Mercury might look like a small, harmless planet, but its unique position gives it a disproportionately large influence on the solar system's stability. Because it orbits so close to the Sun, Mercury experiences significant relativistic effects. Its orbit precesses or shifts slightly with each revolution around the Sun. Mathematician Jacques Lascar from the Paris Observatory ran computer simulations to model the long-term evolution of our solar system. The results were shocking. In about 3.5 billion years, there's a 1% chance that Mercury's orbit will become unstable due to gravitational interactions with Jupiter. If Mercury's orbit becomes unstable, there are several terrifying scenarios that could unfold. Scenario 1. Mercury crashes into the Sun. This would be the most peaceful end for Mercury, but the infalling material could still affect solar activity. Scenario 2. Mercury gets ejected from the solar system. The tiny planet could become a rogue planet, drifting alone through interstellar space. And the third, and most terrifying, scenario, a collision with Venus. This would release energy equivalent to billions of hydrogen bombs, potentially altering Venus's orbit and disrupting the solar system's habitable zone. Even worse, Mercury's instability could trigger a domino effect. If Venus's orbit is disrupted, it could, in turn, influence Earth's orbit. The odds are low, but the consequences would be catastrophic for human civilization. To better understand Mercury's future, Europe and Japan launched the Bepi-Colombo mission in 2018. This dual spacecraft probe is set to arrive at Mercury in 2025, delivering the most detailed data we've ever had about this mysterious planet. Meanwhile, scientists are also developing new technology to monitor Mercury's orbit with unprecedented precision. Even the slightest shift in its path could serve as an early warning for future instability. But there's one aspect of Mercury that might be the most important of all: its role as a Rosetta key for understanding exoplanets. What we learn from Mercury could completely transform how we search for life beyond our solar system. More than 70% of the planets we've discovered outside our solar system are super-Mercuries, rocky worlds that orbit extremely close to their parent stars. Understanding Mercury is the key to understanding billions of similar planets across our galaxy. Many of these exoplanets are tidally locked, with one side constantly facing their star, while the other remains in permanent darkness. Mercury almost ended up this way, but its unique orbital resonance prevents full tidal locking. This makes Mercury a natural laboratory for studying how such planets might retain atmospheres or even host life in their twilight zones, where day meets night. Mercury gives us a natural laboratory to study how rocky planets interact with intense stellar radiation. When Mercury transits in front of the Sun, a rare event that happens only about 13 times a century, scientists get a rare chance to observe how its thin atmosphere interacts with solar wind. This provides crucial insights into how to analyze exoplanet atmospheres. The techniques developed to study Mercury's thin exosphere, especially its sodium and potassium layers, have now been adapted to study distant exoplanets. In fact, the James Webb Space Telescope uses similar methods to detect potential signs of life in the atmospheres of planets orbiting other stars. Mercury also teaches us about the evolution of planetary atmospheres. It's possible that this small world once had a thicker atmosphere, but over billions of years, the relentless solar wind stripped it away. Understanding this process helps scientists predict which exoplanets might be able to retain their atmospheres over long periods of time. Even more intriguing, studies of how Mercury preserves water ice in its polar craters offer insights into how tidally locked planets might harbor liquid water oases along their terminator zones, the permanent line between day and night. This could be one of the most promising places to search for life beyond Earth. Mercury may be the smallest planet in our solar system, but the mysteries it holds are enormous. From its shrinking iron core, its impossible magnetic field, to its role as a key to understanding billions of similar planets across the galaxy, Mercury proves that size doesn't determine significance in our cosmic story. In the coming years, the Bepi Colombo mission will uncover even more secrets of this mysterious world. Who knows? The answers we've been seeking about the origin of the solar system and even the possibility of life beyond Earth may be hidden on this scorched, alien world, so close, yet so different from our home. So, which planet should we explore next? Drop your answer in the comments.